Hello, welcome to the last week of our class and the two assignments that you have that are non-SPSS. This is exercise 14. If you want the original journal article, if you want the whole article, you're interested in this topic, this is where you can find it in the GCU library. What I'd like to take a look at is just where some of these answers are found and make sure that you're completing the answers completely, okay? Number one says, according to the study narrative in figure 1. So figure 1, if I look over here, figure 1 is right here. So we're looking at figure 1, and this is the one that you're looking at and comparing, okay? This is the one that you want to talk about. It says, formula, does the APLS formula under or overestimate the weight in children younger than a year? Not only do you want to say yes or no, but you want to provide, as it says, a rationale for your answer. So to do the rationale, you want to take a little closer look at figure 1. Be specific. What is the formula? What percentage? Why is it statistically the answer is true or false? Come up with, take a look at and quote what the researchers have told you about that. Now, when you get to question 2, it says using these values for the Novell formula, what is the predicted weight? So what you're trying to do is predict weight for a child at 9 months old. This can be, if you go back to the introduction of this chapter, this is where they're going to talk about this, the complete introduction where they talk about the meaning of linear equations. Now, if you might recognize this as y equals bx plus a. A lot of elementary algebra books say it's y equals mx plus b. The variables don't matter just so long as you keep them straight. In this particular case, the b, which you're probably familiar with as m, in, like I said, elementary algebra, is the slope of the line. It is the constant change over time. So this is the slope of the line, and the a in this formula is the y-intercept. Just keep in mind that the numbers that you're looking at, the coefficient of x, that's the number in front of the x, is always the slope. The number that sits by itself, which is added or subtracted to that, is always the y-intercept. So they give you an example here where the formula is given. If A is 500 and B is 20 and X is 28 weeks, then you plug in the formula. X is the number of weeks, and you put this in the formula and get your answer. Now look at when this particular example, when you're doing the problem, make sure that as you look at the research article, what formula did they use? What variables are they using? Notice here in figure 1, it's the age in months that is being multiplied. In the example at the original, back in the introduction to the exercise, they were using weeks. So be sure you're consistent with what the researchers are using. And then show your work, show your substitution, and show your final answer. And you're going to do that for several of the problems. You're going to go through here and do that. What was the sample size of the study adequate? Your rationale should include references to what constitutes an adequate sample size, and compare this to the sample size in the research. You may want to go outside and find some other additional research. You can also take a look. There's some other reasons why. You may find something in the study itself that tells you something. Okay? And 19, the original journal article can be found again in GCU. But if you're looking for, again, we're talking about statistical significance, don't forget to actually state the p-value and then give information with regard to what the values, what its comparison to 0.05. The level of measure. This goes back to the very first week. Remember we talked about levels of measurement? So there was nominal, ordinal, and interval and ratio. So what level of measurement is appropriate for calculating the x-squared statistic? So that's what they're looking for here. And we're calculating, so we want the level of measurement that's going to do this. You may want to again go back into exercise 1 and reread that if you had trouble with that. Give 2 examples of this level of measurement from table 2. So you're going to look at the table 2 and you're going to ask yourself which levels do these variables represent. And we're looking for, once you've decided what level of measurement should be answered in this question, then which variables satisfy that. Okay? Degrees of freedom, again, be sure you state the degrees of freedom and how you arrived at that in your formula. Statistically significant, we've done that many times. Null hypothesis, you're going to want to state that, and then should it be rejected or failed to reject, remember it's based on statistical significance, so you want to tell that, okay? At least one critical advantage and one critical challenge in this. Make sure that when you're doing this, you're going to look at, excuse me, I'm sorry for that noise on my computer. You're going to want to make sure that you look at and see what the researchers came up with for that. How many null are represented here, you want to state that list. Now, this one, the last one, the statistical significant difference between the RAPS users and RAPS non-users. Do the results provide location? And then you want to answer that question. So as you go through these, make sure that you give a full accounting, follow the instructions. Again, you need clarification on any of these questions, or if you, your individual forum, questions to the instructor. This is the last week, let's make it the very best, okay? Good luck.